Okay, so sine of 32, we're just going to type in the sine of 32, which gives us what? 0. Five, let's go to 4 decimal places. 5299. Cotangent. Now remember, the cotangent is 1 over the tangent of 51 degrees. So you can do 1 divided by a tangent of 51 degrees. 1 divided by the tangent of 51 degrees. Or a little bit shorter way of entering it is tangent of 51 and use that x negative 1. Both do the same thing. That x negative 1 is just saying 1 divided by whatever is right in front of it. So that's 0.8098. Same for the secant. Secant is 1 over cosine. So secant of 13 degrees is 1 over the cosine of 13 degrees, which is 1.0263. Good. Cosecant is 1 over the sine. So 1 over the sine of 63 is 1.1223. Perfect. Tangent of 24 is just tangent of 24. 0.4452. And cosine of 60 is just cosine of 60. 0.5. Now the rest of these are going the backwards direction, the opposite direction. So cosine of x equals 0.315. This means just we're solving the equation to get rid of the cosine. We do an inverse cosine, so that cancels out. So the inverse cosine of 0.315 is, we'll just go 2 decimal places for the angles. So 71.63 degrees. Tangent, same thing. We're going to do an inverse tangent to get rid of the tangent. So x equals the inverse tangent of 2.74. 69.95 degrees. Now cosecant. Well, cosecant, remember, is the reciprocal of sine. So cosecant of x equals 1.83. That means that the sine of x equals the reciprocal of 1.83. So we're going to do an inverse sine to get rid of the sine. So when I punch that in, I could do inverse sine 1 divided by 1.83, which gives me 33.12. Or the shorter way of entering is just do inverse sine, the 1.83. Then that x negative 1 key says it's really 1 over 1.83. That's why it's inside the parentheses. That still gives us the 33.12. So now for number 10. Sine x, well, we're going to get rid of the sine by doing inverse sine. So that cancels. X equals the inverse sine of 0.525 is 31.67 degrees. Good. Secant. Well, remember, secant of x is equivalent to the reciprocal of cosine. So if secant of x is 2.155, the cosine of x is 1 over 2.15 or 2.115. So we're doing an inverse cosine. So that cancels out. X equals the inverse cosine of, we could either do 1 divided by 2.115, or we can do 2.115 x negative 1. Is 61.78 degrees. And finally, cotangent. If the cotangent of x is 0.85, that means the tangent of x is 1 over 0.85. So we do an inverse tangent. Tangents cancel out. X equals the inverse tangent. I can either put in 1 divided by 0.85, or I can do 0.85x negative 1 in the parentheses. 49.64. Did that answer your question as to why the x negative 1 has to be inside the parentheses? Okay. Any questions on those? So let's hit our next new stuff here. Just kind of a little bit of a review. See if you guys can remember this. If I tell you that the sine of angle A is 0.6 and the secant of angle A so secant, that is 1.25. Find cosine A, tangent A, cosecant A, and cotangent of A without finding A. I mean, we all know you can just do an inverse sine of 0.6 and find the angle. But I want you to find the functions without finding the angles. I'm going to give you a minute to try that. See if you remember how. So I even put these in an order that made them easy to find. How do we find the cosine? Sine times secant would give you tangent, yes. But the cosine is 1 over the secant. So that's 1 over 1.125, which is 0.8, correct? Once you have the cosine is 0.8, the tangent is sine over cosine, which is 0.6 over 0.8, otherwise known as 0.75 for the tangent. Cosecant is 1 over the sine, so that's 1 over 0.6, otherwise known as 1.6667. Cotangent is 1 over the tangent, 1 over 1.75, otherwise known as 1.3333. Is that what you guys came up with? Cool. What if I were to tell you you could find all those functions if we were only given one? Let's say I tell you that sine of B is 0.4. Why would you be able to find the others? Well, we know if we have sine and cosine, we can find all the others. But how can I find cosine from just the sine? You could find cosecant, but there's a simpler way to get to our cosine here. If we look at our unit circle, sine is this value right here. That's 0.4. So if this is our triangle, this down here is cosine. So if I know that this is 0.4, do I know any other sides of that triangle? I know the hypotenuse is 1, right? It's a unit circle. The hypotenuse is always 1. The radius is 1. So that means to find the cosine down here, it's simply going to be a squared plus b squared equals c squared. I'll label the sides a, b, and c. The sine of angle b squared plus the cosine of angle B squared equals 1 squared. Well, what's 1 squared? 1. So that's pretty simple. So if I want to solve this for the cosine, I subtract the sine. Now the notation we use, we tend to put it as sine squared b instead of the sine of b all squared. It saves us from having to write the parentheses. So we subtract the sine squared of b. That gives us that the cosine squared of b equals 1. 1 squared is just 1, so I don't need the squared anymore. Minus the sine squared of b. And we square root that. So the cosine of b is equal to the square root of 1 minus the sine squared of b. In other words, the square root of 1 minus 0.4 squared. Giving us 0.917. What do you think? Not so bad? Now there's other relationships similar to this that come out of this whole concept. Yeah, go ahead. Yep. Well, yes, it's opposite of hypotenuse, but also remember from the unit circle, the sine is from that point where the angle intercepts the circle down. That sine is that actual physical structure. On this unit circle, there are other structures that are similar to this. So let's take our terminal side of the angle here. Let's look at tangent. Remember, tangent goes from here up, then it intersects the secant out here, right? This is a right angle. This is the tangent of theta. This here, this whole thing, is the secant of theta. Now, this is the distance that's equal to 1. That's the radius of the circle. So which two are the legs? 1 and the tangent. So 1 squared plus tangent of theta squared is equal to the secant of theta squared. Comes right out of our unit circle again. So if I were to tell you the tangent of angle, we won't go with C because that usually is representing a right angle. Tangent of angle D equals 2. I can find the secant. The secant, I would just square root both sides. It's the square root of 1 squared, which is 1, plus tangent squared, which is going to be 2 squared, equals the secant. So it's the square root of 1 plus 2 squared. Let's try that again. Second, square root of 1 plus 2 squared. 2.236. Now that we have the secant, we can find the cosine. That's the secant of d. Cosine of d is 1 over 2.236. 0.4472 is our cosine. And we can go from there. We have the tangent and the cosine. How would we find the sine? Well, tangent of d is equal to sine of d over the cosine of d, right? We know the tangent is 2. We know the cosine is 0.4472. We would make that into a proportion and cross multiply and divide. 2 times 0.4472 divided by 1 is 0.8944 equals the sine of angle D. The point I'm trying to make is there are a lot of relationships here. If you wanted to memorize all of them, good luck. No, actually, I don't have them memorized. If you asked me, is it, 1 plus tangent squared equals secant squared, or what is it? I would actually have to draw out the unit circle like I just did here and come up with that relationship. And that's kind of how I do math. I don't memorize a lot of things. If I can find this concept behind it so I can derive the formula every time, that's the way I prefer to do it. That way I don't have to have it memorized. I can just figure out the formulas as I need them. Otherwise, you try to memorize them and you forget them, or you mix up pieces of it and it comes out wrong anyway. And that's kind of my advice to you guys is don't try to memorize them. Try to understand that unit circle and where the pieces come from off of it. That's why I spent so much time talking about as we go from 0 to 90 degrees, which angles get bigger, which ones get smaller, the cofunctions, the ratio identities, tangent is sine over cosine, and so on. I realize we didn't talk about much today, but I feel like you guys have a lot to do. Yesterday, what was the last page I gave you guys? 702? Or did I give you 702? I gave you 702.34-2. Okay. So today we're going to start. We talked about this part a little bit yesterday. We didn't mention it today. But I want to see how you do with page 705, exercise 34.3, and page 706, exercise 34.4. If you need to, we can come back to that tomorrow on finding missing pieces of a right triangle. Then I'm going to also give you a new page, which is going to be page 347 to 348, and a new paper I'm going to give you. It's problem set 9.2.